Hey, this is Math 6, Unit 2, Lesson 5, defining equivalent ratios. All right, so we have dots and half patterns first of all. So first off, you started today with these pictures, and your teacher probably had them there and then said, okay, we're going to estimate or just do a quick check of how many do you see. And they probably flashed up there real quick and said, okay, without counting, how many do you see? And they made it go away, and then back, and then there, and there. And the idea is that you look at it and you don't want to count them all, but you want to visually see some groupings and then be able to do some kind of quick mental math on what do you see. So for example, you might notice that I have these groups here, and I have groups, and you see that there are 6 groups altogether, right? So 6 groups are existent right there. So whatever I have, I multiply by 6. I also can see that I have basically look like squares with circles in them. And the squares are a 3 by 3. So the area of a square there is 3 by 3 times 6. So 3 by 3 is 9, and 9 times 6 gets you to 54. And so you should be able to do a quick guess or estimation of how many circles are present just by looking at that quickly and just looking for some patterns that you see with the dots. When you look at dot pattern number 2, what you might look at is go, well, this one's a little different because a whole circle is 1, and these are all in half, which means that in reality, we only need to think about having 3. These ones match up over there, so we actually have 3 full row or columns of circles. I don't have to worry about that. They do exist, but I'm going to pretend that they're already connected over there. So I know that one number I'll multiply by here is 3, and now it's just a question of just quickly seeing how many rows do I have. I have 1, 2, 3, 4, 5, 6, 7 rows, so I'd have a total of 21 dots. If I need to do a half, and that is 1, 2, I mean that's a lot of work there, right? I can just recognize that the other halves are here, which goes over there, 3 columns, 7 rows, and we're set. So just things to think about and have your eyeballs start to see things a little differently. Kind of cool. So here we go. We're defining equivalent ratios today. So in activity number 2, it says tuna casserole. Here's a recipe for a tuna casserole. I have not tried it, so if you want to try it at home, by all means, go for it. You cook it up and let me know how it goes for you. But I'm not going to do that. Plus, this tuna casserole looks like it's sitting outside in a garden, so I'm not sure if I want to eat a tuna casserole that's on a table outside in the garden, not covered up. That looks like a fly trap to me, but that's not what math is about today. So we have 3 cups of pasta, 2 ounces of tuna, 10 ounces of cream of chicken soup, 1 cup of shredded cheddar cheese, 1½ cup of French fried onions. So we're going to combine the pasta, tuna, soup, and half the cheese, transfer to a 9 by 18 inch baking dish, put the cheese on top, bake for 30 minutes, 350 degrees. For the last 5 minutes, add the French fried onions, let it sit for 10 minutes before serving. All right, give it a shot. Now, after you've had that, we'll see if you want to do math after you ate your tuna casserole. Question number 1. What is the ratio of the ounces of soup to the cups of cheese to the cups of pasta? So we're looking for the soup to the cheese to the pasta. So I look up here, I see the soup is, right there's a soup, it says 10. So soup gets a 10. The cheese is here, it gets a 1. And the pasta's up here and it gets a 3. So our ratio of soup to cheese to pasta is going to be 10 to 1 to 3. All right, let's use that information over on the next page. 10, 1, 3, 10, 1, 3. I'll just write it up here on top so I have it. So I have 10, 1, 3, soup, cheese, and pasta. All right, number 2. Oops, too far. How much of each of these 3 ingredients would be needed to make twice the amount of casserole? So twice means I'm going to do 2 times each one of the amounts. So what's 10 times 2? That would be 20. What is 1 times 2? 2. And then what is 3 times 2? 6. And that's all they're asking you to do. How about half of the casserole? Okay, so maybe you need to do a little bit of math here. Maybe you need to do 10 times a half, or you might be able to do mentally. So what's half of 10? Half of 10 is, we're doing half now, half of 10 is 5. Half of 1 is a half. And half of 3 can be written as 3 over 2. Think of it like our practice ones we've done the last few days. It's 3 times a half, right? That's why we've been practicing that. 3 times a half is 3 over 2. All right, next one, 5 times. So we're multiplying by 5. 5 times 10 is 50. 1 times 5 is 5. And 3 times 5 is 15. Great. And finally, 1/5. 1/5 is 1 over 5. So 1/5. So 1/5 times 10 becomes 10 over 5, which can reduce to 2. Okay, so that's my soup. For the cheese, it's 1/5 times 1, which becomes simply 1/5. And the pasta is 1/5 times 3, which becomes 3/5. So some different kind of numbers, but that's how you would make 1/5 of the casserole. Why you'd want to make 1/5 of the casserole, I'm not sure, but perhaps you wanted to just try a small sample before you made it for your entire family and served it outside in the garden with the flies. Number 3, what is the ratio of cups of pasta to ounces of tuna? All right, so pasta to tuna. Let's take a look here. Pasta says 3, tuna says 6. So I'll come back over here. And let's do pasta is 3 and tuna is 6. There we go. How many batches of casserole would you make if you use the following amounts of ingredients? Okay, we have 9 cups of pasta and 18 tuna. So we're using this one, right, using these numbers here. So if I'm going to go from 3 to 9 and 6 to 18, what am I doing to the recipe? 3 times what will get you to 9? I got my 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. Does that work out for this one? 6 times 3 is 18. So that's going to make 3 batches of pasta, or sorry, of tuna casserole right there. What if I have 36? Oh boy, that's exciting. So I have 36, 36, read it carefully though. 36 tuna. Oh, they switched it around on us. Oh, those sneaky guys there. And there's the pasta. So what do we have to be careful of? The order of things, right? This is pasta. So pasta is 3. So I'm going from 3 to 18. How do I go from 3 to 18? Well, I have 3, 6, 9, 12, 15, 18, which means I'm single, double, triple, times 4, times 5, and times 6. So that's going to be 6 batches of it. Does that work over here for this 6 tuna? Is tuna 6 times 6, what's it equal? 36. Yes, it does. 6 batches. Not bad. And now we've changed the order back to what it was, from 1 pasta to 2 tuna. So we went from 3 to 6, and we're going to transfer that into 1 to 2. So how do you go from 3 to 1 and 6 to 2? Well, 3 times what number and gets you to 1? Well, again, what we've been practicing, let's multiply by the reciprocal, 1/3. Does that work for the 6? Let's see, 6 times 1/3 equals 6 over 3, which equals 2. It sure does. So that would be 1/3 of the recipe for choice C. Great questions there. Just watch the order so you're not in a hurry. If you get in a hurry and read it without reading it, then you're not really reading it, and then you gotta do it again. So be careful there. Are you ready for some more? I certainly am, but hopefully not more tuna pasta salad thing stuff. Oh, it is. Oh boy. A recipe says to use a 9-inch by 18-inch baking dish. Determine the length and width of the baking dish with the same height that could hold twice the amount, half the amount, 5 times, and 1/5. So this is an interesting question to think about, because you do want to be careful here. Let's say, for example, that I had a 9 by 18 dish, right? Okay, think about area. If I'm going to make twice the amount of casserole, do I need to double both sides? Think about area, right? If I double both sides, what happens to my area? If I was to double this and double this, I'd have to fill in that space. What happens to my area? It's 4 times as much, isn't it? So I actually don't want to double the whole thing. That would be crazy. So don't do that. Instead, when you're doubling a recipe, I just want to make 2 pans of it instead of 1. Which one shows 2 pans? This would be 2 pans like that, right? So I just need to double 1 length there. That's what we have to keep in mind, this whole activity. So if I'm going to make twice the casserole, I can double the 9 times 2 is 18, and I keep the other length the same. For an 18 by 18 pan would work. Okay? If I want to make half the amount of casserole, I don't have to do everything half. If this is my starting part here, I can just cut half of it there. So what do I have? I have a 9 by 9 pan. That would work there. 5 times the casserole. Again, I don't want to have to multiply all those out 5 times. I just need to do one of them times 5. I'm going to go ahead and take the 9 times 5 because it's a little easier and do 45 by 18 is the size of the pan you would use. Not that that exists anywhere, but we'll go with it. And then 1/5 of the casserole, let's do 9 times 1/5 to get 9/5 by 18. Okay? Again, you could do other numbers too. I could have doubled this other one, the first one here, and made it 9 by 36. That would work. Over here, cutting things in half, I could have done a 9 over 2 by 18. I could have multiplied that by 5. I could have this one by 9 by 18 over 5. So there are other answers there, but this is what we did here. Okay, and next one. The ratios 5 to 3, 10 to 6 are equivalent ratios. Is the ratio of 15 to 12 equivalent to them as well? Okay, let's take a look. Let's do the 5 to 3. Let's use that as our starting point. I want to use it as a starting point because I already know that 5 times 2 is 10 and 3 times 2 is 6. So if I'm going to go to 15 and to 12, let's start with a small number. 5 times what gets you to 15? Times 3. Well, 3 to 12 is 3 times 4. Those are different amounts, aren't they? To be equivalent, what I do to one item, or side, I have to do to the other. So these would not be equivalent ratios there. It's not going to work. Okay? I could double check it by using the 10 to 6 because someone might say, well, but wait, with the 6, maybe the 6 might get us closer to 12. You're right. 6 times 2 gets you to 12. But what is 10 times 2? 10 times 2 is 20, and that says 15, so that's not quite what we want either. So that's why those numbers were chosen, but either way, it's not going to be equivalent. Okay? So let's go back to our 5 to 3, 10 to 6. Looking at number 2, using the same ratios, we know we have 5 to 3 and 10 to 6. So is the ratio of 30 to 18 equivalent? Well, let's take a look. Again, I can use either one. Here's 5 to 3. Here's 10 to 6. We're looking to try to get to 30 to 18, 30 to 18. 5 times what will get you to 30? That'd be times 6. Does that work there? 3 times 6 is 18? Yep, that's okay. How do you get from 10 to 30 over here? Times 3. And what is 6 times 3? 18. That works as well. So in this case, both of those would work for this one. Again, it doesn't have to. It would have to be both because we know these are already equivalent. So once one works, the other one's going to work as well. Okay, give 2 more examples of ratios equivalent to 5 to 3. So 5 to 3, we've already done. What did we do first? We did times 6 already, and we've done a times 3-ish. Well, sort of. Let's do a times 4. If we did times 4, we would do 5 times 4 is 20, and 3 times 4 is 12. That could work. And if we did a times 5, we would do a 25 and a 15. That could work for that one too. Again, you can pick any example you want there. So how do you know when the ratios are equivalent and when they are not equivalent? Okay, so we know they're equivalent when you multiply both parts by the same number, and that's the way it works. If you don't multiply by the same number, then they're not going to be equivalent. Okay? So the definition for a ratio. A ratio okay. So a ratio is equivalent to A, B when both A and B are multiplied by the same number. So a ratio is equivalent to A to B when both A and B are multiplied by the same number. And that's the big takeaway from today. So let's look at our summary, because it says it again in a little nicer handwriting than mine. I know my handwriting's not very great. All right, here we go. All the ratios that are equivalent to AB can be made by multiplying A and B by the same number, right? So to get from 9 6 to 8 to 12, we're multiplying by times 2 times 2. Works out great. If I'm going to go 9 to 3 and 6 to 2, we can multiply by fractions, times a third. But when I look over here at this one, 9 to 18 is actually times 3, and 6 to 15 doesn't even work, so it's not going to work. That's a big old nope, not going to happen there. Oh, sorry, times 2. I was looking at the 6, so times 2. And 6 times 2 is 12, so that's not going to be the same, right? So you have to multiply by the same number on both sides in order for it to work. Let's pause there, then we'll come back and look at homework together. All right, homework time. Each of these pair of equivalent ratios, there they are. For each pair, explain why they are equivalent ratios, or draw diagrams to show they are equivalent. All right, so let's explain or show why. So why does 4 to 5, why is it equivalent to 8 to 10? Okay, so again, you could draw a diagram, or you could simply recognize that to go from 4 to 8, I'm multiplying by 2, and I multiply 5 times 2, and I also get to 10. You could draw a picture, right? You could do 1, 2, 3, 4, and 1, 2, 3, 4, 5. And we could do it again and get 1, 2, 3, 4, and 1, 2, 3, 4, 5, and show, I'm just doing A's and B's here, that 4 A's, 5 B's is the same as 8 A's and 10 B's. That's kind of a drawing of how that would look as well. Okay, 18 to 3, 6 to 1. Okay, we could look at 18 to 3. I'm going to do it the harder way, okay, and go 6 to 1. How do I get from 8 to 6? That's going to be 18 divided by 3, or times 1/3. 18 times 1/3 is going to be equal to 6. 3 times 1/3, hey, that's handy. Reciprocal is 1. So indeed, both of these, when you multiply by 1/3, get you the other one. It'd be easier to guess, yes it would be, to go 6 to 1 and 18 to 3 and recognize that this way it's times 3 and this way it's times 3. Does it matter? It doesn't matter. Our goal is to show how it's equivalent. And finally, C, we have 2 and we have 7. You want to show how that's connected to 10,000 and 35,000. So crazy big numbers, but this is simply going to be multiplying by 5,000 for both of them. 2 times 5,000 is 10,000, and 7 times 5,000 is 35,000. So crazy numbers, but it works the same. Number 2, explain why 6 to 4 and 18 to 8 are not equivalent ratios. Sure. Well, to go from 6 to 18 is done by doing multiplying by 3, right? 3 times as much. But 4 to 8 is multiplied by 2. Because those are not the same numbers, not multiply the same thing, they are not going to be equivalent ratios. Are the ratios 3 to 6 and 6 to 3 equivalent? No, and the reason is 3 to 6 is times 2, 6 to 3 is multiplying by a half. Those are not the same again. 2 and a half, while they're the reciprocal, are not the same, therefore they are not going to be equivalent ratios. Number 4. This diagram represents 3 batches of light yellow paint. 3 batches. Yay. Draw a diagram that represents 1 batch. Alright, so let's take a look what we have. It's 3 batches. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 there. Now I want to break this up into 3 different groups. So let's do 9 divided by 3 equals 3. 15 divided by 3 equals 5. So if I draw a line right there and draw a line right there, I have batch number 1, batch 2, and batch 3. And 5s, 1, 2, 3, 4, 5. Draw a line there. 1, 2, 3, 4, 5. Draw a line there. And we have our batches, which are all the same amounts. And we have 3 batches. 3 to 5 is the ratio that we have for 1 single batch of light yellow paint. All right, number 5. In the fruit bowl, there are 6 bananas, 4 apples, and 3 oranges. For every 4 apples, there are 3 oranges. The ratio of something to something is 6 to 3. Here is 6, here is 3. Get the order right. Bananas, 2 oranges. Okay, we're still using our 6, 4, 3 for bananas, apples, oranges. 6, 4, 3, bananas, apple, oranges. Just my notes. The ratio of blank to blank is 4 to 6. So 4 is apples, and 6 is bananas. For every 1 orange, oh boy, there are how many bananas? Okay, well, to go from 3 to 1, I'm going to multiply by 1/3. So 6 times 1/3 is going to be equal to what? 6/3, which is equal to 2. So for every 1 orange, there are 2 bananas. It's a great little question there. Something you want to start thinking about, like, oh, I multiply by the same thing, the same factor there. Works out great. Okay, write fractions for points A and B on the number line. This is the number 1. Here is 0. So we have fractions 1, 2, 3, 4, 5, 6. There are 6 spaces between here and here, which means that this is fraction 1/6. This is 2/6. I have 3/6, 4/6, 5/6, and 6/6. Now 6/6 is 1, 3/6 is a half, 2/6 can be reduced to 1/3 if you wanted to, and 4/6 can be reduced to 2/3 if you wanted to. But there are 6 spaces, so we're going to group them all by a denominator with 6, and that's the way that one works right there. That's it for today. Have a great day, and we will see you next time.